Hey guys, so today I'm going to talk about Reynolds number, its significance and its derivation. So the very first thing, what is Reynolds number? So Reynolds number is a dimensionless number which helps in determining the flow regime or the type of flow in a fluid. So basically, as you know, there are two types of flow. One is laminar and another is turbulent. So these are the two regimes. So what happens in laminar flow is that the fluid is assumed to be flowing in the form of layers, and this is the velocity profile obtained. So the fluid is assumed to be flowing in layers in laminar flow, and in turbulent flow what happens is the complete mixing occurs in turbulent flow. So this is laminar flow and this is turbulent flow. So second, coming to the definition of Reynolds number. So this is the ratio of inertial forces to the viscous forces, right? So next, coming out to the formula, that is Re, which is written as Reynolds number. I mean, it's abbreviated as Reynolds number. So what is it? Is the ratio of inertial force to the viscous force. So how do we write inertial force? Force, since it is of kind of force, so inertial force is, I can write it as rate of change of momentum. So d by dt of mv. So as we know from Newton's second law, the rate of change of momentum is directly proportional to the force applied. So this is called, actually this is the force. So I can write this is the, so this m is the mass of the fluid into velocity of the fluid. So we can further simplify it down to d by dt of mass of the fluid. I can write it as rho of fluid, then rho into v, volume of the fluid. So volume of the fluid, I can write it as area into length of the fluid, next as it is vf. So again I'll just simplify it to rho f a vf d by dt of fl. So what will this come? This would be rho f a vf into this dl over dt is nothing but velocity, so this becomes vf square. So this is the inertial force, right? So now coming to the viscous force, so from where we'll get the viscous force? So viscous force is from Newton's laws of viscosity. From Newton's law of viscosity. So what does Newton's law of viscosity state? It states that the shear stress acting is directly proportional. So I'm removing the directly proportionality constant, which would be the viscosity into the velocity gradient, the directly proportional to the velocity gradient. So dv is the velocity and I am writing it as dy. Okay, so this is the sign convention. This is the typical sign convention. This is shear stress. This is the shear stress, and I'm making a Cartesian. I'm explaining a little bit about this. I'm making a Cartesian coordinate. So I'm assuming it to be y, and this is, sorry, I'm writing this to be x and this to be y. So the shear stress, suppose I'm taking a fluid flow in a pipe and the fluid is flowing in the form of layers. The shear stress, basically the shear stress is in x direction. Okay, the shear stress is in x direction. So how it is represented? So basically the direction, I mean the suffix tau is written, then the direction is written as x. So this is the direction, and the y is the perpendicular. The y is the perpendicular. So this would be tau, and this would be tau yx. So y is the perpendicular to the direction of force. It is normal to the direction of force. So this is how the sign convention is. So this is the shear stress, and you can write it as force per unit area, right? And the mu is the viscosity, and this is the velocity, and dy you can assume it to be this is the length, and you can assume it to be characteristics length, right? So now I'll write it down as force. So this is a viscous force. So how we need to write it down? So if we multiply it by area, suppose mu, the mu is the viscosity, mu into area into velocity. So velocity as it is, I'll write it down, and this characteristics length, I'll be writing it down as d. Okay, so did you get it? So this is actually the force. So this area has been transported over there. This is actually the force. So this is the viscous force, Fv. So this is the viscous force. So overall, a final expression, I'm just calculating it out. So this Reynolds number is equal to the inertial force. I'll write the inertial force as rho f a vf square to the viscous force. So this is the overall viscous force. So viscous force I'll write as mu into a into v, this is the velocity of the fluid, divided by d. So finally what we get is Reynolds number is equal to d, the top, d would be migrate to the d would be over the top, d v, this vf cancelling out, dv rho over mu. So this is the final expression of Reynolds number. So just a minute, I'll be telling you all the, just hold on, yeah, it's fine. So this what does this d implies? This d is the characteristics length. This is the characteristics length. This is the v is the, this vf is the velocity of liquid, rho f is the density of the liquid, density of liquid or any fluid you can consider. Mu is the dynamic viscosity. So mu is the dynamic viscosity. So remember, there are two types of viscosity. One is dynamic viscosity and another is kinematic viscosity, right? So the dynamic viscosity is represented as nu, which is the mu divided by the density, right? So nu is the dynamic viscosity. So in another form, nu is the kinematic viscosity. So in another form, we can write it down as Reynolds number is equal to d, characteristics length, into velocity of the mean velocity of the fluid divided by nu, which is the kinematic viscosity, right? So this mu is the kinematic viscosity, right? So these are the two types of Reynolds number which we have talked about. So now one more important thing is just the Reynolds number for a circular pipe. So for a circular pipe, Reynolds number less than 2000 is called, this flow regime is called laminar flow, right? Reynolds number greater than 2500, I'm sorry. Reynolds number greater than 3500 is termed as turbulent flow. And Reynolds number in between, which is less than 3500 and more than 2000, this is the transitional region. This is called the transitional flow or transitional regime. So Reynolds number less than 3500 to greater than 2000 is termed as transitional flow. So I hope this video is very helpful in your case,